Hello and welcome to Mr. Pena Has Flipped. This is video lesson number 19, standard form of quadratic functions. And that's what the standard form of a quadratic function looks like. F of x is equal to ax squared plus bx plus c. But you got to remember that a is not equal to 0. It can be any other number besides 0. Okay, and some characteristics is if a is positive, the graph opens up. If a is negative, the graph opens down. Kind of seen that before. If a is bigger than 1, you have a vertical stretch. And if a is between 0 and 1, you have a vertical compression. Alright, now to find the axis of symmetry, we're going to do it a little bit different. Okay, the formula for that is x is equal to negative b over 2a. And to find the vertex, well, first you're going to use negative b over 2a. Then what you're going to do is you're going to plug whatever number you get into the original quadratic equation to find the y value of the vertex. See, so you have like f of negative b over 2a, and you plug in negative b over 2a in every x in the original equation. We'll see that in an example in a second. And so the vertex would be, the x part would be the negative b over 2a, and the y part would be whatever you get after you plug it into the quadratic function itself. Here's example number 1. For the following quadratic function, find the axis of symmetry and the y-intercept and the vertex. Okay, and the formula there is you have negative f of x is equal to negative x squared plus 8x plus 3. The first thing you need to find is a, b, and c. So a is negative 2, b is 8, and c is 3. Okay, so the vertex, we're going to plug in the numbers a and b into negative b over 2a. So we have b is 8, so we get negative 8 divided by 2 times a, which is negative 2. So negative 8 over negative 4 is equal to 2. Alright, so here's where we get the number. We're going to plug in the x value that we got here, and then we're going to plug it into all of the x's here. Okay, we got that one there, and then we got that one there. Okay, so we're plugging it in there, and we're plugging it in there. Alright, so the vertex, after we plug in the 2 into the original equation, is going to be 5. That's the y. So the vertex is 2, 5. The axis of symmetry is 2, which you've seen before, which is the x value of the vertex. And the y-intercept is 0, c. That's kind of a new thing right there. So make sure you make a note of that, 0, c. So in this case, c is 3, so the y-intercept is at 0, 3. And that's it. Okay, example number 2. You have f of x is equal to x squared plus 2x plus 5. Now this time, they're asking you to find the vertex, axis of symmetry, y-intercept, x-intercepts, the point symmetric to the y-intercept, and then graph the equation. So once again, we're going to find a, b, and c first. A is 1, b is 2, c is 5. And we're going to find the x value of the vertex, which is negative b over 2a again. So negative 2 divided by 2 times 1, it's negative 2 over 2, which is negative 1. That's your x value. To get the y value, we're going to plug in that negative 1 into all of the x's into the original equation. Okay, we're going to plug it in here and here. Okay, the negative 1. When we do that, we get 4. So the vertex is at negative 1, 4. Axis of symmetry is x is equal to negative 1. Y-intercept is at 0, 5. And the graph is on the next page. And there's the graph. Now, one thing about this graph is it does not have the x-intercepts. And so in this case, I just kind of didn't even bother with those. So here's the y-intercept right here. Here's the axis of symmetry. The point symmetric to the y-intercept, if I'm here at the axis of symmetry, and I go 1 over, so I'm going to go 1 over the other way. So that's the point right there. So that's where this number comes from. I'm going to go -2, 5. Okay, and that's it. We'll do some more examples in class, and look at the problems in your SSPs to get more of an idea of what's going on also. And thank you for joining me. See you in class.